Alright, well today I'm going to talk to you a little bit about the descriptive statistics that is used. Try not to fall asleep, I promise it won't be that boring. Alright, one of the most important things that I've run across in my study of statistics is the mean. I don't think that there's one time where I haven't had to know the mean of some sort, whether it be sample, population, etc. Which brings me to the point that there's two separate entities. Your sample mean, which is denoted by X bar, is completely smaller in size compared to your population mean. And when I say smaller in size, it's a subset. Like your sample is a subset of your entire population. I like to think of it as if I wanted to look at some pattern in migration of birds. I don't know why I would, but if I did want to, it would be really hard to find the mean value of whatever variable I want to take from their migration for every single type of robin. Because there's no way I can meet every single type of robin. So then I would use the sample mean to estimate what I want to know about that migration. The formulas for the sample mean and population mean are very similar. You're going to sum up all of your data points or variables for the numerator, and then you're going to divide that by the number of data points you see in the denominator, which in the sample mean is denoted by a small n, large N for population mean. You can do this with categorical data. Let's say you want to look at fruit sales. So you could look at apples, oranges, grapes, pears, etc. Usually it's for numerical or nominal data, like your dollars spent. So that's the example that I want to share with you today. We're going to calculate a mean together. I just took a bunch of numbers that are going to represent the amount spent at, let's say, Walmart in a given aisle for an hour. You add up the entire numerator, get a sum of 77. Well, then we're going to go back and count the observations that we're looking at. We get 11, so divide the two. Your mean dollar amount spent is 7. Now let's move on to the next descriptive statistic, that'd be the median, which we heard a little bit about. When you were taking a median, you were looking at the very middle number of your data. And that's hard to do with even numbers. So for odd number of data observations, you just take that middle value. When you have an even number of data points, you find the two middle values and you average them and call that your median. For my example with the dollars spent though, I had 11 observations, so then we can just take the median, or the middle value, because it was an odd number. So our median of dollars spent is 7. Our mode is the most frequent observation that shows up. So with our dollars spent number, our mode will be the one that shows up the most. That happens to be 8. $8 is spent more frequently in that hour than the rest of them. And now Savannah will go through some more details.
Alright. Also, the mode is easy to incorporate with categorical data. We have another example of mode, so this is going along with the fruit sales. Disregard the axes, and we're just looking at how many times these dots show up. And the bottom blue and the top blue are different. The bottom is tomatoes and the top is apples. And we can actually count the dots, and the orange dots show up the most at 30 times, which is pairs. So in this scenario, the mode is pairs. It's kind of hard to count all the dots. We can then move on to percentiles. So say you have a data set and you organize it from least to highest, or however, put it in a particular order, and then you pick one observation, and you can pick that one observation will be in a certain percentile. You can then cut all the data into quarters, which will give you quartiles. In descriptive statistics, you can have your first quantile, which is the lower quantile, is the 25% of the data at the bottom. Your middle quantile, the second quantile, is 50% of the data and below, and then the upper quantile is 75% of the data, leaving the top quantile just the top 25%. For example, say we have a classroom of 20 students, and we're just looking at their height. We order them from shortest to tallest, and say that you are the person in blue, point of view. You are in the 80th percentile in this circumstance. Another example is birth weights of female children from the age of 0 to 2. So at the beginning, you can see that weights are a lot more closely related. On the right-hand side of the graph, it does say very small numbers, the quantiles. Obviously, the very top bar is a higher quantile than the below ones. And for example, the first kind of turquoise dot, you can say at 6 months, this child is in the 15th percentile if you just follow the points on the graph. If you say that it weighs 6 kilograms, or a little over 6 kilograms, go over, and then 6 months old, you can see that she is in the 15th percentile, and you can do the same thing for the other 2 points. This information may be boring, but it is informative and necessary. Even knowing what a quantile is, like you hear this day to day. When you have a child, you're going to want to know if they're in an average weight range for their age. Is there any questions?